In the 19th question, we have something interesting, very interesting. What do we have? Sine inverse root x minus cos inverse root x. How will we handle this? In the denominator, you have sine inverse root x plus cos inverse root x. That is simple, right? This denominator is equal to pi by 2. Yes. So I is equal to, in the denominator, if you have pi by 2, do you see that this sine inverse root x, I can also write it as pi by 2 minus cos inverse root x. Yes. So this becomes pi by 2 minus cos inverse root x minus another cos inverse root x will be this dx. This is what we are looking to integrate. Yes. Okay, let's divide these to 1 minus 2 upon pi by 2 is 4 upon pi cos inverse root x dx. So 1 is easy, 4 by pi is not an issue. We are interested in this cos inverse root x, this integral. So let's try to find this integral somehow. Let's focus on I1. If you can find this, then life would be very easy, right? Okay, you'll be able to get I very easily after that. So this is cos inverse root x. One of the ideas is to apply by parts directly by taking first function as this, second function as 1, right? Or another idea could be to use substitution first. So let's use substitution. Cos inverse root x is equal to t. What does that tell me? Put this. Root x is equal to cos t. Okay, and x equal to cos square t. What about dx? Dx will be equal to 2 cos t into minus sin t dt, which becomes minus of sin 2t. 2 cos t sin t is this dt. This is what you get. Okay, therefore this I1 becomes equal to what? Integral of cos inverse root x, which is t. Dx is minus sin 2t, there is a minus sin 2t dt. And now I can apply by parts on this. After making this substitution, now I can apply by parts. There is an algebraic function, a trigonometric function. This will be taken as the first function u. This will be taken as the second function v. This is what you will do. So therefore I1 will be equal to minus 1. That comes out common. In the bracket you will have first function times integral of second function minus cos 2t upon 2. That's the integral of the second function minus integral of derivative of t, which is 1. Integral is minus cos 2t upon 2 dt in the square bracket. What does this give me? So this is not difficult. Minus minus becomes plus t by 2 cos 2t. And this minus becomes a plus, but with this minus it becomes a minus again. The integral of cos 2t is sin 2t upon 2 plus a constant of integration. This is what you get. Is that okay? Yes. Okay. And what about these cos 2t and sin 2t? We have cos t as root x. So I can write cos 2t and sin 2t in terms of this cos t and then substitute it as root x, right? Okay. So this I1 will be equal to t by 2. T is cos inverse root x. 1 by 2 cos inverse root x times cos 2t. Cos 2t is 2 cos square t minus 1. 2 cos square t, which is 2 under root of x square, 2x minus 1. Minus 1 by 4 is okay. Sin 2t is 2 sin t cos t. Okay. Cos t is this 2 root x. Sin t will be under root of 1 minus cos square t, which is under root of 1 minus x. This is what you get, plus a constant. So we have almost simplified this. This is, have we taken care of that minus? Yes. This is 2x minus 1 by 2 cos inverse root x. And this is minus 1 by 2 root of x minus x square plus constant. But is this a final answer? No, this is just the value of I1. Let's write the value of I. Therefore, I will be integral of 1 is x minus 4 by pi. I1 is what we are looking forward to. I1 is this 2x minus 1 by 2 cos inverse root x minus 1 by 2 root of x minus x square and multiply this with this, make this C prime or C1 for that matter. That's the constant of integration, new constant of integration over here. This is my final answer for this question, as you can see over here. At max we can multiply with this 4 by pi inside and we will get a slightly different form, but this is the final solution and the final answer for this question.